Hello everyone, and welcome to another Tech Tuesday brought to you by CamLogic. My name is Mark Anderson, and I'll be your presenter today. I have 20 years in manufacturing, everything from running CNC machines through management. I specialize in NX CAD, NX CAM, and Solid Edge. I've been an application engineer for over 12 years. And today what we're going to talk about is feature recognition, grouping feature types, creating feature processes, and editing tools and updating your program. So let's get started. First, we're going to discuss the beginning steps of doing a feature-based program. There are 4 things that NX requires to be able to produce the feature-based programming, which is your WCS, your part, your stock, and your check boundaries. So when you go in here to do this, we're going to start with our WCS. And you'll find the WCS in the Operations Navigator and in Machine View. So let's go into NX and I'll show you. So what we're going to do first is I want to just do this to make sure that everybody is opening and creating or operating off of setup templates the correct way. So we're going to open this file. We're going to go ahead and open a plate that I've already had pre-modeled. So right now, if you look, you can see that we're in Gateway. So we can't start programming off this yet because we're still in the model. So we need to go, you always should follow this routine. File, New, and it'll bring you to manufacturing, referencing an existing part. The unit of measurement will default to the properties of the part. We're going to choose General Setup for this one. And these are just the naming conventions and where the file is going to be saved. So when you're okay with these settings, you hit OK. Now it's going to bring us into a manufacturing template. And you can see that the suffix setup_1 has been added. So now we're in the machining environment and we can get started. The first thing I'd like to show you is up here in the top right hand side is where you can find your features, your feature buttons. But I'd like to use the right click method because it's quick and right here. So the first thing that we want to do in our Operations Navigator as we follow along with the PowerPoint, we want to orient our WCS first. And this will be our machine work 0, our G54, our part 0. So we need to have that represent what it will be in our machine. So let's do that. This is our Operations Navigator here on the left hand side, and up here is our views. So we're going to go into the machine view. We'll expand this here. We're going to double click the MCS. So now we have our dialog to orient our MCS. The central button here, CSys dialog. In the drop-down menu, I'm going to choose this 3 planes. This is always a good one to start with. So we're going to select X direction. This part is going to be sitting like this on our machine. So for our X, we want our work 0 on this side here. Our Y direction is going to be here, and our Z is the top surface. You always have to select OK to save your settings, but you can see our Z is opposite. So I'm going to hit this dialog, and I'm going to choose Dynamic, just so I can double click our Z, bring it up to where we need it to be. And that would be correct for a 3-axis mill. So we're going to go ahead and save this. And now that our work offset is correct, we're going to double click our workpiece. So if we go into our PowerPoint, so our workpiece, our WCS, we set that. Now we're selecting our part, and select the workpiece button as we did. So now we have specify part. We're going to select this, select our workpiece, specify a blank. We're going to select this. This will give us different options to be able to create on-the-fly geometries. Now if we had a part in our Operations Navigator or Assembly Navigator here that was a stock body that was added to this assembly, we could then very well select that. We would just want to select geometry and then select it. But for this, we're going to choose bounding block. And remember that with NX, if there is no material, it will not cut it. So I'm going to go to this ZM so we have some facing stock and put 50 thousandths in there. So I'll hit OK. So now we have our flashlights where we can view what our items are. So I'm going to hit select OK. Now I'm comfortable with those. So now we'll go back to our PowerPoint, see where we are. We always have to hit save to save our selections. So now we have our part selected, we have our stock selected, and I showed you where the drop down was. Now we need to select check. And check would be anything that we do not want the machine to run into. So if we had clamps or I'm not sure the size of this part off the top of my head, but if it was in a vise, we would want to select the vise. And that's what a check boundary is. So, and that's specified here, specify check. And that will keep the tool away from those items. So now that we have our minimum set, we can go in and start recognizing features. And in the Machining Feature Navigator, select Find Features. Right-click the part, select Find Features. And NX will show on the bottom the progress and what feature types have been found. So let's find these features. This here, on the left-hand side, you see it's the Machining Feature Navigator. We'll select this, expand, right-click. I choose to do the right-click method because I like to stay right here in this dialog. Or you can go to this Find Feature button here on the top ribbon. So we're going to choose this Find Feature. Now there's a few things you want to take into consideration when you're using this. You can see that the part is selected already. So what we're going to do, we want parametric recognition, the geometry to search. We're going to choose workpiece. We don't want to choose mapping our features, but we do want to check all of our recognitions. The machining axis direction, we can choose a direction or we can allow it to find everything. But for this particular part, just to save us time, I'm going to select specify a vector. Well, now that I can do it a couple different ways. I can choose in this blue triad here, I can choose this z-axis arrow, but I like to go and select the surface, and you can see how our arrow is projected straight up. So now we have our vector. It's looking down at the part that direction. So, and we're going to hit the Find Feature button here. You can see here at the bottom it's recognizing features, and it'll showing you here what features were found. In this Recognize Feature box, you can scroll through here and look at individual features that were found to delete any that you don't want. So we're going to hit OK. Now you see that now our features have been populated in this list. What I like to do right from here is group the features because it flows in a natural progression. So before going any further, I want to catch up with our PowerPoint. So we have found the features and it's shown where we are. The Machining Feature Navigator, you will see the features that were found. The arrow shows the axis direction, the vector direction. So you see these arrows here, that's just showing the work zeros and where our z-axis is and how they're going to be machined down, which is correct. So we want to remove any feature in that view that is not needed. If it had picked up, if we selected all features and it selected features from the bottom, we would want to delete them before we moved on, or we would only want to highlight what we want for the top of the part. So now we're going to group the features, and by grouping the features, it organizes things for us. So what we're going to do is, just like the PowerPoint says, we're going to, in the Machining Feature Navigator, we're going to select all features. And then we right-click the features and select the Group Features option. And you can see that NX groups all the features into individual feature groups. So we're going to select, you can choose this here in the More, or you can go in here and group features. So here in this feature type, it shows all the features that can be grouped together. So out of these, I don't know, 10 or 12 items, it's going to group them into 6, which is, for us, that's organization. We like that. So and we're going to hit Group Features. Now it brings these down here and it shows us what we have. We select OK. Now up here in these two buttons right here, it shows the feature groups or just the features. For this process, I leave it in just the features. But for organization's sakes, I like to have it here so I can edit these in groups instead of individuals. So with all of these selected, I'm going to create the feature processes. And in the Machining Feature Navigator, I'm going to highlight all the features, right-click, any one feature or in the group of features, and then select the create feature process. Now NX will go out to the library for tooling. It will access the machining knowledge editor and knowledge database, and it will pull features and machining operations that were pre-programmed for that type of feature, and it will create your operation. Hello everyone, I'm going to jump in real quick and pause myself. All this talk that I've been talking about on the machining knowledge database and the tool library, I want to show you the complexity of it and where is it exactly pulling this information from and how do I access it. Well, if you have just an out-of-the-box package, then all you can do is access the information and change the tools, as I'm going to show you later. But for it to access different tools and different operations, there's a couple things that take place. One thing is when it creates the tools and it reaches out to the library to find those tools, what is it looking at? What is it trying to find? Well, if you go into your menu button here and go into Tools, you can look down here that says Edit Machining Data Libraries. Then you have several options: Machining Data, Cut Methods, Tool Materials, Part Materials, Tool Machining Data, all the machines that are loaded in your machine, in your computer, and you can see I have several additional ones that are before they get into the sims that come out of the box. And you can do imports. You can import speeds and feeds. So I'm just going to import speeds and feeds, and it says 2,296 records were processed and stored in the library. So that's how you get to your different machining data libraries. And let's go in and look in the tools again and see what else is available to us. Convert a tool library. So you can have a library that's an Excel sheet and convert it into a library, and it'll walk you through the steps. So now also this machining knowledge database, what is that? Well, you have a database that's preloaded in the machine that contains rules for all of the operations. For this hole here, the system looks and says, okay, that's a step 1 hole because it only has one step in it. A counterboard hole would be a step 2 hole, and so on, step 3 hole and 4. It's just the different diameters in there. It can even be a step 2 hole thread, so that'd be a counterboard threaded hole. So let's look at this machining knowledge editor, but you have to have the author license to be able to manipulate this. And there is no link from NX to get to this. You have to go to your start menu, all programs, go into the version you want to change, into manufacturing, and here this machining knowledge editor, select that, and it's going to bring up just this page here. So we have to go in and open. Well, it's going to go right to the NX10 mock resource machining knowledge folder and pull up your different machining knowledge. Out of the box you get these 3, and I've just made a copy of this for my rules. So let's open my rules. While it's loading all these, I'll explain to you what you have to do for tools. When you want the system to pick up a new tool, you don't have to modify the logic and the rules behind how it processes the operation. You just have to, when you create a tool and you modify a tool after a feature has been made, if you create a tool in a program and you don't save it to the library, export it to the library, then it's only valid in that program. But if you create a tool, a special tool that you may use again, or a holder, you always want to go and export that to the library. So I'm going to show you that real fast. So I'm going to create a tool. We're just going to pick something really quick. Pocket. We're going to have this drill. That's fine. 8 drill. All these different things. Let's change it a little bit, and we're going to go 135 point. Just to be different than the out-of-the-box tool. Okay, now when you go here, library, you want to export tool to library. You can actually export an entire part file, a model of everything if you would like to. But we just want to export to library. Select the target class. That was just a regular twist drill. Now we want a holding system. We can have all these different holders if we want to. And that's just out of the box ones. If we have a holder built on, we're going to select none. But if we just want to, if we know what it is, if it's a 100 parallel 20, then we can throw them on there from this phase. But we don't. I always just create a holder as well. So when it says this is created in the metric tool library, no tool part file was saved because we didn't select that box. Check the system log for more details. So now that tool can be selected by any other program and any other time that you've used the find feature processes. It will find that tool again. So when we go into the knowledge editor here, we go into the expand the recognition. These are the different things that it can find information on. If you have all the holes, slots, steps, surfaces even, it'll try to program you surfaces that are not normal to the tool axis. Bosses. So when we go in there here and look at any of these, let's do one that's semi-difficult and see how it figures those out. We'll do a step 3 hole. It's telling us its priority, step 3 hole thread. Now when we go into machining knowledge, this is the type of program language that it requires in this. It's a different type of syntax that's particular to this, but it's the same syntax that's used throughout NX as well. So if you know how to customize NX script at all, then you'll be very, very functional at this. And in this, there's different functions on how it finds the different operations that it's going to find. So when we look at this, it's setting a string to result to ask the mom variable. So when it pulls up this code, it's going to look up other code and different feature statements, if it's true or if it's false, and where does it go from one place to another place. And we look at this, and this is different language here. So if it pulls up those different strings of code, it's going to pull up these rules, and it's going to say if the rule is false, then it is rejecting it. The rem tool attributes, it's saying the tool diameter is cut diameter equal to the flow diameter, the MWF diameter 1. The tool pilot diameter is less than the diameter 2. And if this is less than diameter 1, then it's equal to less than 2. That's the different operation language and the different syntax that it requires in the knowledge database. There's different conditions, materials, machines, explanations. You have to know how to put all of this in the right order and make it the logic to where it can be solved or reconciled, or it will just kick you out alarm saying it cannot be recognized. So I wanted to show you guys where it was finding this information and how this information was working in the background, and so you can have an understanding of what it really takes to pull these operations and the tools out of these libraries. This is a very strong, robust feature of NX, and you'll find that any type of plate machining, within 5 minutes you can have, even out of the box, you can have you could probably have 90% of your program already laid out for you, that you just have to change tool diameters and adjust things to fit your tool crib. If not, having the author license to come in here and set your own features. And if you're running CAM Express to where NX isn't your primary CAD system, we can take attributes from the other CAD systems, 3D models. For example, if an M10 in CATIA always shades that feature in red color 157, then we can set rules in here that states whenever red number 157 is seen on a part, that is always going to be an M10 hole. And we can set up the logic to where it pulls the center drill, tap drill, and tap for the M10 hole. And that's how the find features and create feature processes work. First, NX runs the engine to find its own features or other features with the rules that are in the knowledge editor. And then NX takes the features that were found, cross-references it with operation data, and finds a tool that can create that feature. Then NX takes that tool and that feature and it creates a feature process, which is your operations, to make the hole. So it's a very robust, very powerful, very powerful tool. And once you get used to using it, it will reduce any type of plate manufacturing, and especially if you get the author to where you really drill down these operations and drill down the tools and reduce the amount of reconciliation that can happen. So there isn't multiple attempts for it to solve, different methods. So if, for instance, if I was running this in a mold shop or a stamping die facility to where there was a ton of holes and pocket features and flat plates, I would take the time and buy the author and create my rules and eliminate the rules that I don't want to solve for that feature, to where I know that my tools will be found correctly and it's sitting in my tool crib. I know that my operations are going to be set right so that I know it's going to cut in the way I intend it to cut. And I know that from part to part, my tools and my features are going to be consistent. So you can have consistency with going to a 24-hour running time, doing a lights out manufacturing with even these types of manufacturing products like large plates, very costly steels and machines. But you gain the confidence to know that the part that you're making is going to come out the way that you intended on it being, because you have confidence in many previous programs and you know it's going to follow suit with what you want to do. But I just thought it was very important for you guys to know where this information was coming from and how it was being determined. So now I'll let myself get back to finishing the original. We're going to right click, create feature process. You can see down here at the bottom it's going to start telling us our progress, and it's going to show the features that were found. But before, we have to select what we want it to find. We're going to use the machining knowledge database, and these down here are just the different options that are available to us. And our location is our workpiece. So I'm going to select OK, and now it's going to show us that our operations are being generated, and we have a total of 20, and it's showing our progress. So while that's running, let's catch up our PowerPoint. So once it creates the processes, NX is going to use tooling that's already in the database, but sometimes it's going to pull up tools that are not in your tool crib. So if it creates a process that's going to use an 1.5-inch twist drill, we're not likely to have, but we might have an 1.5-inch insert drill that we can run in its place. So what I like to do at this point is I go into my operation navigator and I go into my tool view. I'm going to expand all this. You could do this also from machine view. You expand and it shows us our drills and all of our operations. So what I'd like to do now is show you how to edit these tools to make them more consistent with your tool crib. Because if you think about the different operations, if it uses an end mill to open up this pocket and it chooses a 1-inch end mill, well, we might want to use a 1/2-inch end mill. So it doesn't matter, it's going to still circle mill that out. Or for these pockets, we want to change that end mill size to something that is something out of our tool crib. But by doing so, it's going to change our in-process workpiece, and it's going to change our operations. So if I go in here to our program view, expand these nodes, select my top node, I think what I'm going to do right here is this is actually a lathe operation, because I didn't deselect turning in that list. Now I'm going to generate the toolpath. So I have toolpath laid out before I start changing tools, so that I can show you how it goes back to out of date after you modify something that has been already generated. And by changing the tool diameter, we are changing the operation and everything that follows after that operation. So I want you to see how it flows and how you can modify this to suit your needs. And you can see that it's work in progress. It takes a second to generate all these different lines here. So we'll catch up our PowerPoint. When you group the features, you want to look at all your tools, find the tools that are odd sizes, and then change the diameter, length, and the holder to something that's in your tool crib or in your machine. And then you got to update your program. And you'll see that once we have features, we're going to have a question or an explanation point here saying that status is good. Now what we need to do is we need to go into the tool and we need to see, okay, what is this tool? 22 diameter end mill. 22 millimeter, that's not very common, but a 19 millimeter is very common. That's 3/4 inch. So when we select OK, you're going to see that it's going to say you have modified a tool that was retrieved from the library. Do you want to keep your modification? Yes, of course we do. So now you see how it's affected these two. So I need to generate this toolpath. And you can see that it's just going to update that path to accommodate the new tool diameter. So we need to update this one as well. And then NX just finds the simplest tool that it can find. We just got a 12 millimeter diameter NC drill is fine. That will work. We're using a carbide drill 11.3. That's a tap drill for a M12. Go ahead and keep that, it's fine. This is a 50 millimeter twist drill. Well, that's a perfect example. We're going to go ahead and change this to a 0. Oh, it has to have an angle because it's a twist drill. But what we can do is we'll cancel the edit, go into another pocket, right click, insert tool. We're going to create a drill. But this, for a inserted drill, the system is not going to like that it has an angle to it, or does not have an angle to it. So we're going to have to tell it that it has some type of angle, and we'll put 50 millimeter insert drill. Select OK. We're going to define this 50 point angle. We're going to make it 180. That'll be flat. We can go ahead and move this to see it. So we're going to make this length more accommodable, 100, probably 150 is a more adequate length. This is going to be, we'll make this 10. The inserts are going to be about 10. This is going to change to carbide for our speeds and feeds. Then we're going to want to grab a holder. And I like to just go and grab something out of the library, retrieve holder, milling, drilling, and just grab one that is going to work for us. Turn our preview on, display it. Not so great. Large, no, just move through here. That looks fine. And we're going to choose our insertion. We need to put this in something. So it's 150 long, and we're going to put this in 50 millimeter. Select OK. Now what we're going to do is drag this here up to our drill and see if we can't insert that. Take these operations, drag them to our 50 millimeter drill, and then update. Okay, now we need to go up here, delete this tool. Okay, and then what I like to do is I just like to move my tool up to the next, the one I deleted, so that everything is consistent. So we're going to generate this. And you'll see that it does a very good job. Okay. So we're just going to go through and see fixed diameter boring. That's a boring head, which is fine. Generate the toolpath here. So I can bore out our holes. Accept the path. What do I have here? This would be a countersink, an 80 millimeter countersink. So we're just going to generate this. The principle is just to show you that you don't have to keep the tools that are generated for you. You just want the format. You want it to do the programming for you, and then you can just go through and change your diameters to something that's more accommodates you. And then after we have all these toolpaths generated, we're going to check out how NX handles feature-based manufacturing and how good of a job it does all for you with just once you, this was an explanation of the the operations, but if I was to actually program this, it would only take me 3 to 5 minutes to do that. We're going to choose 3D Dynamic. So you can see it's machining the pockets out down to the floor. And you remember I didn't select anything. All I selected was the part and told it to do the hard work. And you can see that all features were done. All features were done well. And I didn't have to intervene until the very end when I needed to change a few tools to something that was more adequate for our tool crib. So I would like to open up for any questions. If you have any questions, feel free. If you think that something will help you if I dive in deeper, don't hesitate to ask. And you can go ahead and email me at any time, and I will give you a quick response. And if you need to talk, you can call the helpline between 8 and 5, or email the support at camlogic.com, or you can call the office phone and ask for the support AE that you would like. Thank you for attending, and here's some information about our next Tech Tuesday, the first Tuesday of every month, and next month is myself doing NX Cam. And once again, thank you for watching. Hello everyone. I'd like to thank you for attending our Tech Tuesday.